This is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to look at few applications of stacks. What do you mean by stack? Stack is nothing but a linear data structure in which data is stored in such a way that last inserted element will be removed first. It relies on the funda LIFO, last inserted, first out. So coming to the applications of this data structure, stack data structure, it is mostly used for evaluation of an expression. As humans understand just infix expressions. What do you mean by infix expression? Have a look at this one. So any expression in which an operator is embedded by operands is nothing but an infix expression. Say, if A and B are two operands and they are concatenated by an addition operator press, such an expression is known as infix expression. As I said, humans understand infix expression, but for evaluation, the system does not understand infix expression, especially in the cases where we have brackets in view. For example, divided by C minus D. To evaluate such an expression, the system cannot differentiate between these brackets and operators. So, with the help of a stack, it converts an infix expression to postfix expression, then evaluates the postfix expression and gives us the result. Right? So, stack is one of the most important data structure one must learn when they are trying to understand the working of a computer. Internally, how arithmetic logic unit works, right? So, in the evaluations, the primary one is, as I said, infix to postfix conversion. The other may be parenthesis balance. For example, I have opened a flower bracket over here. This is an outer one. Inside, I open another set of brackets and I close it. This is closing off inner bracket, and this one is closing off outer, right? So parenthesis balancing. Whenever you take a stack, as I said, it will be closed from one end. Insert the flower brackets one by one as soon as you encounter whether it is open or closed. First of all, I'm going to encounter the first open bracket. I'm going to insert it into the stack. Second open bracket, I'm going to insert it to the stack. As soon as I encounter a closing bracket, I'm going to pop an open bracket from it, saying that it's matching. Closing bracket is encountered. And at last, when I find another closing bracket, I'm going to remove the open bracket within the stack. With this, you can see that the stack is empty. We started with an empty stack and we have an empty stack in our hands. Thereby, we can say that the set of brackets which we have declared is full. That is, it is complete in one sense. It is balanced one. If I have a bracket something like this which was inserted and which do not have a matching closing bracket, then such a pair of brackets are unbalanced one, which are syntactically wrong. To check the syntaxes of our program, stacks are used. The compilers or the interpreters are going to use these stacks to check parenthesis balancing. So today we are going to talk about one of the major applications of stack. That is, first of all, let us understand what infix expression is, which I have explained just now. Then what a prefix expression is, and then what a postfix expression is. Right? So for a given example, as I said, A plus B. The prefix expression says that place the operand as the first element or the first character, followed by operand 1 and operand 2. Postfix says that first of all place the operands, operand 1 and operand 2, followed by the operator. Right? These are the three kinds of expressions which we find when we work with computers. Let us look at few examples of the same. Right? Here you can see that the first one which we have already seen, the second one, have a look at this one. We are going to start from left to right? So when we start from left to right, operator precedence comes into the picture, right? So first of all, over addition, multiplication is having higher priority. So in case of A plus B multiplication C, first of all, B multiplication C, the prefix is formed like this, where the first operand is A and the second operand is multiplication BC. Now again perform the prefix operation plus A star BC. This is how you are going to get the prefix expression. If you work in the reverse order for the same, you'll get the postfix expression of the same. Let me explain you the same. For example, A plus B into C. As we start from left to right, multiplication is having the highest priority. So B, C multiplication becomes the first evaluation, where A is the first operand, second operand is BC star. So post of this one is first operand followed by second operand followed by the operator. So have a look at this one, postfix expression of the given one. This is how we are going to evaluate. First of all, we are going to traverse from left to right, keeping the operator precedence in mind. Let me explain you this with one more example. Yes. Okay, let me take one of the examples. Let me take the last one. Okay, you might be feeling that it is difficult. Let me explain you the same. Here they have given nested brackets, right? So let me explain you the same. The expression is A plus B multiplied by C minus D. So let me do the prefix first. We convert this into prefix first. The innermost bracket always have the highest priority. So A, B plus will be converted, as we are doing prefix. Operator must come first. So plus AB star C minus D. Now, if you keenly look into this one, the outer brackets gets the next priority, right? Where plus AB is the first operand, C is the second operand. When we write prefix of the same, first multiplication comes into the picture, then the first operand which is plus AB, then second operand C minus D. Now have a look at this one. Multiplication plus ABC is the first operand, D is the second operand. When we write pre of the same, minus star plus A, B, C, D. This is how you are going to get the prefix expression of the given infix expression. If you try to evaluate if you try to get the postfix expression of the same, you have to do it you are going to do it in the same manner, no change in that, but in the reverse order, right? Placing the things in the reverse order. That's it. Let me do the same, post order of the same. The innermost will get the highest priority. So AB plus multiplied by C minus T. I have used these brackets, guys. Don't get confused. Just to differentiate that I have evaluated it, I have used these brackets. But in the actual sense, they are not required because A plus B is already converted into postfix. Brackets are not required. Okay. Now, in this expression, A, B plus acts as the first operand, C acts as the second operand. When we evaluate it, A, B plus C star becomes the postfix expression of the given infix, where this part AB plus C star is the first operand, D is the second operand. Let's write the postfix of the same. A, B plus C star, the first operand, followed by the second operand, followed by the operator. Have a look at this one. A, B plus C star T minus. This is the postfix expression of the given infix expression. And all these conversions, we can convert not only an infix expression to prefix or postfix, we can convert a prefix expression to postfix, vice versa, using stacks. Stacks are used as an intermediate agent for these conversions. Let's have a look at one of such applications, which is converting a given prefix expression to infix expression. So the algorithm goes like this. So read the prefix expression in reverse order. That is, generally we read any expression from left to right, right? But we are going to do it from where we scan the given expression from right to left. That's why I have clearly mentioned it as reverse order, highlighted it. Next, if the symbol is an operand, push it into the stack. We will get only two types. You might have seen that in prefix and postfix expressions do not have any brackets. Only infix expressions have the brackets, right? So as brackets are not there, we have only two categories. Either the character which we are going to read can be an operator or an operand, right? If you face an operand, push it into the stack. But if you encounter an operator, pop two operands from the stack, okay, perform the operation, whatever operator you have encountered, concatenate it and push it, the result into the stack, right? So this is the expression. So top and the element next to the top, you are going to pop, concatenate them using the operator which you have encountered, place them within the brackets. Guys, have you seen this? I have explicitly mentioned brackets. String is equal to, open the bracket, operand 1 plus operator plus operand 2, close the bracket. Here plus operator is nothing but a symbol of concatenation. Okay, it doesn't go straight with the addition operator. It means concatenation, and that partial result will be enclosed within brackets and the result will be pushed into the stack. So this we are going to do repeatedly. If it is operator, pop two elements, concatenate, push the result. If it is an operand, simply push that operand into the stack. We are going to repeatedly do this unless we we come to the end of the string or not. Once you come to the end of the string, your stack will be left with only one element in the total stack, that is at the bottom. Or you can say that top will be pointing to index 0, right? So that is the case where you can feel that the given expression is converted. That is the converted into infix. That is the end of the prefix expression. Okay, let me explain you this phenomena with an example. Consider this prefix expression, right? First of all, for a rough sketch, you can count the number of operands and operators. So let's count the number of operands. 1, 2, 3, 4, 5, 6, 7, 8. 8 operands are there. Operators 1, 2, 3, 4, 5, 6, 7. 7 operators. Okay. Operands are 8. Operators are 7. So to concatenate 8 operands, you need 7 minimum operators, right? And they are there. So you can, and on a rough note, you can say that yes, it is, you are going to get a balanced infix expression, proper infix expression by the end of this process. So take a stack. As I said, we are going to traverse in the reverse direction from right to left. The first character that is encountered is H, which is an operand. So I have pushed it into the stack. Second one is G. Even that is an operand. I pushed into the stack. Next is F. Even that is an operand. I pushed into the stack. Next comes my operator, which is minus. What did I tell you? Pop 2 characters from the stack, concatenate them within brackets using the operator, and push the result into the stack. That's what I have done. I have popped F first, then the top is going to point G. Place them within the brackets. Use the operator that is encountered, which is minus. Now push this result into the stack. Can you see on top of the stack you have F minus G, right? Very good. Now the next operator that is encountered is plus. Have a look at this one. After minus you have the symbol plus. The same process. Concatenate. First of all, pick one, perform the operation, and then push it into the stack. Right? So I have done the same. Next element that is encountered is E. Push as it is an operand. Push into the stack. Next, D. Even that is an operand. Push into the stack. Next is an operator. So as soon as you find an operator, pop the elements from the stack, perform the operation, that is concatenate with the operator, push the result into the stack. So I have first concatenated D, then E, placed within the brackets, concatenated them using the operator, which is minus. And I pushed the result into the stack. So here is the answer, D minus E. Right? So next, even next is an operator, guys, which is division. Have a look at this one. You'll encounter division. So have to do this one. See, you have two elements in the stack, right? As a whole, D minus E acts as a single unit. H plus F minus G acts as a single unit, right? So two elements are there in your stack and an operator in your hands. You can concatenate them. That's what I have done. So D minus E slash, you can see clearly that I have used brackets to concatenate them, right? As I said and as I promised, I have used brackets, right? So with every concatenation, you are going to come up with a new pair of brackets saying that this is the new product, right? So come on, let's continue the process. I'm going to continue with the leftover element in our stack, but the string is not yet over. The next character to be considered is C, which is an operand. I'm going to push it into the stack. Next is B. Even that is an operand, so I'm going to push into the stack. Next comes an operator, minus into the picture. So pop the elements, B, then C, concatenate them with the operator which you encountered, which is minus, and push it into the stack. This is very simple. The element which is on top will become operand 1. Next one will become operand 2. Operator is in your hands, right? That's why you have come to this situation. Now you have to concatenate simply. Have a look at this one. Operand 1, operator, operand 2, and put them in brackets. That's it. Very simple task. Okay. So this is how you are going to concatenate and place. Next character that you are going to encounter is an operand. So push it into the stack. Now you can see that A is on top of the stack. B minus C is next to it. Okay, I'm going to carry forward the last or the current status of the stack to the next slide. Okay, very good. Now, what is the character next you are going to read, which is addition. As it is an operator, pop the top two elements from the stack, concatenate them using plus operator, and push the result into the stack. Have a look at this one. I have concatenated A and B minus C with plus operator, and I have placed brackets or enclosed them using a pair of brackets, right? The next character is multiplication. This is the last one, and I hope you can see that only two elements are there in this stack. We need not worry about this right now. So I have concatenated A plus B minus C is concatenated with D minus C by H plus F minus G. So you can see that the end, you have reached to the end of this string. That means you have reached, as we are traveling in the reverse direction, we can say that we have reached the first position of the string, and even we have considered that also. That is star symbol, right? And in the stack also, you can see that only one element is present in the stack, which is pointed by the top. If you go for indexing, guys, if you go for indexing 0, 1, 2, 3, and so on, am I right? Then the top is always going to point to the most recently inserted element, and the most recently inserted element is at index value 0, right? Remember the first, recollect the first words which I have used, guys. Say, by the end of conversion, you will have a single element in your stack or you can say that at index value 0, right? So now you can say that it is the end of the string as well as a single element in the stack reveals that this is the correct conversion. This is the final answer, final infix expression for the given prefix expression, right? Prefix to infix. We have converted this. Have a look at this final result carefully. Each and every intermediate, or I can say each and every sub-binary operations which we have performed, we have placed them as a single unit. For example, B minus C, it is a binary operation which is enclosed within brackets. Or you can say D minus C or F minus C. All are units. Or you can say binary operations which we have performed and placed. And you can see that how it is differentiating, right? So have a look at this one. For example, if I consider H plus F minus G, here H is the first operand, F minus G is the second operand. F minus G, which is clearly enclosed within brackets, right? So this is the perfect conversion of a prefix expression into infix expression. Guys, you can go for reverse engineering and cross-check your answer. Convert the given infix expression to prefix by closing or by hiding the given question and then cross-check. That is one of the kinds of reverse engineering which generally I do to check whether I got the right answer or not, right? So this is one kind. Okay. A small extension for this one. We have seen that in this example how to convert a prefix to infix. Then, as I said, we have three kinds of expressions. That is, we can even convert prefix expression to postfix also. Right? First battle we have won. Now we are going to go for the second. That is conversion of prefix to postfix. Right? Let's go through the algorithm of this scene. Okay, so read the prefix expression in the reverse order, just as we have done the conversion in case of infix expression, right? So read the expression from right to left. If you find an operand, push it into the stack. These two steps are as it is. But if you find an operator, pop the two operands from the stack. This is fine. But how you are going to concatenate them? You are going to concatenate them in this way, right? Operand 1, operand 2, and operator. That is, the intermediate binary statements which you get are converted into postfix. Previously, for conversion of prefix to infix, as we were thinking of converting that into infix was in our minds, we made it stay like that only. Every binary operation to be a binary form only. But here, in this case, I want prefix to be converted into postfix. So, I am going to convert the intermediate results, binary operations, into postfix. That is the only change, right? So I'm going to do this repeatedly unless I reach the end of the prefix expression, right? This is a short exam algorithm on prefix to postfix conversion, for which we are going to use stacks for this conversion. Let me explain you the same with an example. I'm going to take the same example, my dears. So this example, I have converted this into infix. Then I'm going to directly convert this into postfix. And I am using that word directly. Guys, there are two ways of conversion of the same. So convert the given prefix into infix, then convert the given infix to postfix. This is one of the methods. Prefix to infix, I have just shown you. Infix to postfix conversion is covered in my previous videos. Guys, please check it once. I have covered it already. That is infix to prefix and postfix conversion. So thereby, for the given prefix expression, you can convert it into postfix by evaluating an intermediate one, that is intermediate form infix expression. This is one first case, or you can directly convert your prefix to postfix. This is another case. So here there are in the first case 2 steps are involved, whereas in the second case only 1 step is involved. But in all the 3 steps, we are going to use stacks as an intermediate element. Okay, so I hope the first one you understood. Let me explain you this part. Let's start from right to left. The first one that is encountered is H. As it is an operand, push it into the stack. Next one is G. Even that is an operand, push it into the stack. Next, F. As even that is an operand, push it into the stack. Once you encounter an operator, what you are going to do? That is the question. What did I tell you? Pick the operands, pick 2 operands, or pop them. Okay, then convert the intermediate binary operation into postfix expression and push the result into the stack. So I have done the same. Right? I have popped the first operand, next operand, concatenated with the operator F, G, minus. And this expression I have inserted or pushed into this stack. You can see on top of the stack is F, G, minus. Right? So what is the next character that is encountered? Which is plus. How are you going to do this, guys? Pop. Again the same point. Pop the elements. So have a look at this one. The top element is F, G, minus. The next element is H. And the operator they are talking about is plus. And this is the result which you got. Right? F, G, minus, H, plus. Right? See, we are, guys, try to understand this one. Do not get confused with operand 1 and operand 2. Be very careful. The top element will act as operand 1. The top will act as operand 1. And the one below it will act as operand 2. Okay? Please remember that, because on the other side of the coin, we are going to take it in reverse order when we convert postfix expression to prefix. So, okay. Now let's move. Now the next character to be read is E. As it is an operand, push it into the stack. Next is D. Even D is an operand, push it into the stack. Next is a character, minus, right? As it is a character, pop the elements. D, E, minus, right? So as I pop it, this is operand 1, operand 2, concatenated with the operator, which is minus. Now I'm going to encounter slash, which is division test. What do you think? How it is going to happen? Very simple. Try to understand. DE minus is the first operand. F, G minus H plus is the second operand. Slash is the character that is going to get concatenated. Right? So merge them and push it into this stack. I'm going to push it into this stack. Have a look at this one, just cross check. DE minus FG minus H plus slash. Right? This is how we are going to convert. After slash, we are going, next character that we are going to read is C. It is an operand, right? So simply push it into this stack. To move forward to the next slide, I'm going to carry forward the same last bit. Okay. Next character that you are going to encounter is B. Even that is an operand, right? So push B into this stack. Next is minus. As it is minus, right? So it is an operator. I need to pop. So B acts as operand 1. C acts as operand 2. Operand 1, operand 2 and operator. That is B, C minus. This is nothing but a resultant. Right? So minus is over. Now the next character is A. As it is an operand, push it into the stack. Once you push it into the stack, the next character is an operator. Again, guys, the same point, don't get confused. Operand 1, operand 2. Concatenate with the operator which is plus. So A, B, C minus plus is the result that you are going to get. The next character in our hands is multiplication. Once you reach there, have a look at this one. I concatenate it. So A, B minus and plus A was there on the top, and below it was this expression DE minus FG minus H plus slash followed by the operator. Right? Have a look at, have a keen look into this. Okay. This is how I'm going to get the final postfix expression for a given infix expression. Using these fundas, you can convert any expression into a class of any other type. So you can take any example, guys, then you can convert and try to check and go for a reverse engineering. I am saying reverse engineering is, follow my next video where I'm going to tell you how to convert a postfix expression to prefix. Okay, you can take this postfix expression and check whether you are going to get this prefix expression or not. You can cross check anytime, guys. You can do that. Okay, so this is the basic conversion. Coming to the point of stacks, here you can see that each and every time we were using stacks as an intermediate agent to convert prefix to infix or prefix to postfix. All these expressions, conversions of these expressions will be carried out in our arithmetic logic unit for arithmetic expressions evaluations, where stacks are most prominently used. Stacks are not only meant for, as I said, for this expression conversion, they are also used for parenthesis balancing also, and many more applications of stacks are there, like recursion, function calls. Say you have a function. Let me give a small example of the same. Say for example, you have a function which is calling another function in its due course, function 1, and this function 1 is going to call function 2 in return, and function 2 is not going to call anyone, it is going to just end. Then how for example, function 2 working is ended. Now, how it is supposed to remember where it must go after completion of function 2? So to store the intermediate written addresses, we use stacks. Let me explain you with this small memory addresses. For example, function 1 is stored at location say 2000, okay, and in due course at 3000 location function 1 got broken, right? The control. Right? So store the written address say considering this as the top of the stack, okay, so 3000. So the control will go to the function, it will evaluate, right? So function 2 is at some location 4000. Now it is supposed to go to function 2. The 4000, the written address of function 2 is also pushed into the stack. Now top is pointing to 4000, right? So the control will break and go to function 2. The execution is over. Once the execution is over, then the control will directly go to the stack to retrieve the written address where it is supposed to go, which is pointed by the top field. So top is pointing to location 4000. So kindly go to the location 4000. It will go back to the location where it lost its control, right? Because of function call, right? So it will resume with working with function 1, completed, task done. Meanwhile, as the location 4000 is used, the stack is going to pop it. Now top is pointing to the new element which is 3000. Once execution of function 1 is over, it is supposed to go back to the function who have called it, right? So for that purpose, it will approach the stack and it will ask, where am I supposed to go? It will show that on top of the stack, whatever the location is there, please go there, which is location 3000. So the control will go to the location 3000, which is actually within the body of the main function, right? So it will execute the remaining body of the function and it will end, right? So this is how stacks are used to store the written addresses of the functions. So the basic applications of the stacks are, as I said, three. I have explained you all the three in this video itself. One is the basic one is for expression evaluation, parenthesis balancing, and storing the written addresses of function calls. Right? The stacks are wonderful data structures which have the beauty of not allowing the data to be pushed or popped from the other end, or you can even say that when we work with stacks, we have access rights only to the element which is on top of the stack. Either you can push an element to the top of the stack, or you can pop the element pointed by the top of the stack, which is generally termed as peak element, right? So the data hiding or data is secured when we store that in terms of a stack. We can never compare a stack with a queue, right? Because queues allow the data to be accessed in both the directions. I don't mean that they allow in both the directions for insertion as well as deletion. It has its own working style, like insertion at the rear end and deletion at the front end. So both the ends of that structure are pre-dedicated or been predefined with operations. But here, in the case of stack, pick up whether you can talk about push or pop, both must be carried out from a single end, right? So with this, I hope you understood what what a prefix expression is, postfix expression is, infix expression is, and how to convert a prefix expression to infix as well as postfix expression, right? So, and the basic applications of this tag. In the next video of mine, you can see how to convert a postfix expression to infix as well as prefix expression. I hope you are following my videos, guys. Thanks for calling. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.